This comment may seem odd, but Git can play a significant role in your network operations strategy. At this point, the basics of Git should be a review, but let's summarize them in a slide. Git is a distributed version control system that has a local and a remote component. On the local side, there are three main stages that describe the state of a file. A file can be in your working directory, the staging area, or committed in the local repository. When you make changes to a file, those changes occur in the working directory and Git observes those changes. If you want to keep those changes, the first step is to add them to the staging area using git add. If you didn't mean to stage your changes, you can unstage them using the git reset head command. All we are doing is changing the location of the file in the Git process, not editing its contents. I like to think of head as a pointer to your current location. Assuming you want to keep the changes, you can commit them to the local repository using git commit and supply a commit message describing the updates. Even after changes are committed, you can travel back in time to an old commit using git reset followed by the commit ID, which is a SHA-1 hash. Suppose we want our code to be accessible beyond our local development workstation. We can introduce a remote repository for that. Code that is committed to the local repository can be pushed to the remote repo using git push. You can think of this like an upload action. You've seen me use this command several times over the past few courses to kick off CI/CD pipelines, for example. In the reverse direction, there are two general choices. Git clone is used when you want to initially download a remote repo. Git pull is when you are actively involved in a project and want to download any updates committed by other developers and merge them into your working directory. Let's imagine a doomsday production scenario where Git is part of the solution. Suppose you've already pushed your code to GitHub and kicked off a CI/CD pipeline. Your code has been automatically deployed to production and suddenly the entire network collapses. How do you react? If you answered git reset, that could technically work, but would be complicated as you'd need to first identify a past commit, discard all intermediate commits, then push back to GitHub. That could lead to a merge conflict, not to mention the possibility of orphaned commits and a lot of headache. You definitely lose your Git history as well. Even for projects that only use a local repository, the loss of history is a significant issue. Instead, consider using git revert. It's considered a forward-moving undo operation because instead of actually traveling backwards in time, it travels forward in time and applies the inverse of the previous changes. This also gives developers an opportunity to add in a commit message explaining the revert while also retaining the complete Git history. You can easily push these changes again, which will undo the destructive change, assuming our deployment system is declarative in nature. In the next clip, let's explore git revert in the context of our Puppet VLAN management system.